Okay, so we're going to talk about the difference between continuous versus discrete change. Now this is kind of an important concept because it leads us to yet another transcendental number. So like pi is a transcendental number. It leads us to another one called, get this, E. So what we're going to be looking at is probably maybe an equation you've seen already in science, and there's a reason you've seen it in science, is this, which is exponential, obviously, and this. Now I would like to point out that these two equations are actually identical. It just so happens that E here, E is a constant, and I'll try to explain where that comes from. And E is approximately equal to about 2.718. Kind of like pi, it keeps going on forever. It's an irrational number, all right? But so when you're looking at this, we use this equation here, this P equals P naught, P sub 0, right? P sub 0 is considered the initial. P sub 0, that's the initial, okay? Now this subscript notation, like if I was looking at P sub 1, that would be after 1 whatever, year, minute, second, whatever. P sub 2 would be after 2 minutes, seconds, whatever. Whereas P sub 0 would be the 0th minute, or when we started, the initial, okay? That, believe it or not, does say initial. But that being said, beyond subscript notation, we're looking at, well, I'm going to match up, at least, just for your own edification, these different terms. Now, we know that x is the independent variable, right? Independent variable. Y is the dependent variable. This is the stretch, the vertical stretch, right? Or the initial value. Y-intercept, start value, same thing. And B is the base. Now, this matches, believe it or not, piece by piece to this equation, except for one part, ERT. Now this is R times T. I am going to consider this as a unit. Remember, E is a constant, it's 2.718, so just think of it as a number, raised to R, which is some other, well, we'll talk about exactly what it represents here in a sec, but represents this value, this rate here, okay? So what this means is if you're matching stuff up from an exponential to an exponential, because you're both exponential, this x and this t are both the independent variable. The base, the b, is equal to all of e to the r. That is, it's still what you're multiplying by. A, right? This works both ways, right? Is your p naught, your initial, and y is the same as your p. So that's your dependent variable, okay? So this is how these pieces match up. Remember this. This is very important. It makes your life a lot easier moving forward. Honest, it does. Okay, so let's talk about continuous versus discrete. So when you're talking about continuous change, you're talking about something that's changing, get this, continuously. So often when we think about population growth, we think about that as continuous change. And here's why. Whoops. Now, population growth is often expressed in terms of an annual rate. So often we'll have a population growth of 3% per year. Now, please bear in mind, this is a continuous change. Believe it or not, right? The stork doesn't show up only once a year, and that's not how things work anyway. But people have babies throughout the course of the year. It does not mean that we have a growth of 3% in the population. So if you think about the population, let's say the population's 1 million, right? 1 more 0, that's 1 million, right? In January, okay? And then in December, the population is still 1 million, but then at the end of December, we get this fresh influx of babies. In other words, you get our 3%. That's not how it works, okay? What happens is over the course of this whole time, the population gradually grows, continuous growth. Now it's going to be fits and spurts, but you're going to have a 3% increase, which by the way is 3,000, right? That's 1,000 thousands, so actually that would be what? 3% would be, we chop off 2 here, and that'd be 3 of those, so it'd be 30,000 kids that we'd have added, right? So 30,000, it would be at the end of time 030. That would be our population by the time December hit. We'd see a 3% increase over the course of the whole year, all right? So that's what we get where we have continuous change. And it turns out that this E, P equals P naught, see, and that's where this is based off of. The population equals initial population times E to the R times T. Typically, T is expressed in years for things like this. If it was population growth of something else per month, then T would be in months. We'll look at some examples as we move forward. But R would be the rate of growth in this case. So if we're looking at 3% population change per year and it was continuous change, we would write it as follows. P equals P naught, we still don't know the initial population, whatever it may be, right? It's a number. E to the, well, we convert this 3% into a decimal times T, right? So you take the 3%, you convert it to a decimal, and then this, it would be, because it's continuous change, what we'd be looking at, okay? A lot of things end up being continuous change, except for money, where it actually ends up being what we call a discrete change. So when we're looking at continuous change, the R is our rate of change, and if R is greater than 0, if it's positive, then it's an increase, and if R is less than 0, then it's a decrease. Okay? So, meaning, when we're looking at this, if we had a 3% decrease in a population, or let's say we're talking about a 3% decrease, I don't know, in whatever, right? P equals P naught E to the negative 0.03 T. Remember, this reflects it. So what it does is it changes this growth, E to the 0.03, into decay. And before we get too much farther here, I'm going to do a quick calculation. I'm going to figure out what E to the 0.03 is and what E to the negative 0.03 is. Remember, these are just, and they just end up being numbers, which means that when you're looking at them, they're right around 2.718, but I'd actually use an E button in your calculator. So give me a sec here, I can actually get to it. There we are. So if you look on your calculator, or if you go to Desmos and you just type in E, so you can E, and then you can raise that to a power, and we're going to raise this to the, where am I? Oh, I's failing here. X to the Y, 0.03. E to the 0.03 is equal to 1.030454, and I'm going to go to this many decimal places. I'll explain here in just a sec. Whereas if I'm looking at E to the negative 0.03, so 0.03, negative sign, no negative sign. I get, oh, there it is. Negative is 0.97044. Let's go with 5. Okay? Now, if you take a look carefully at this, hey, 1.03. If I told you something was increasing by 3%, you'd take 100% plus 3%, you get 103%, which would be 1.03. If I said a 3% decrease, you'd say 100% minus 3%, and which would be 97%, which would be 0.97. So it turns out when we have continuous change, be it an increase or a decrease, it is slightly different than if we just have a raw percent increase or decrease that is considered to be discrete. I'll explain discrete here in just a sec, but if we're talking like money or something like that. It turns out when we continuously change something, we're changing it over a much finer interval, and we'll see with this when we start talking about compounding, such that the actual increase is a little bit more than 3%. And here the actual decrease is a little bit less than 3% when we're talking about a decrease. But as you can see, E to the 0.03, hey, that's right around 1.03, which is what we'd expect for a 3% increase. And E to the negative 0.3, which would be a 3% decrease, is right around 0.97, which is what we'd expect, okay? Now, when we're talking money, though, money, which is the biggest and most popular example for discrete change. Now, discrete simply means it does not mean discrete with two E's and then the T, which is, not telling people they're, don't look good when they don't or something, but being appropriate. Discrete means we're talking about at a given time or interval. So if we had a discrete change in money, like, and this is how banks operate, like they talk about what is called quarterly interest. What that means is every 3 months, which if you think about it, that's a quarter of a year, right? Every 3 months is when you get your interest. So let's say you're getting 1% interest, right? And you're getting it every quarter. So let's say, just for argument's sake, this is not actually how this works. We'll talk about this in the next video. But let's say you have 1% interest every 3 months. That would mean you would have, let's say you had $10 in your account in January, right? Then you kept it in there for February, you'd still have $10. No, not 10%, I'm sorry, $10 to make that look right. Otherwise it's gonna be confusing. You had $10 in January, you'd still have $10 in February, and then March, $10. So you had it in all January, all February, all of March. At the end of this, and in April, right, the very end of March, they pay you this 1% interest. Now 1%, that's 1/100th, right, would be what? Well, this is 10.00, so 10 times 0.01 would be, you'd get a dime. So then, and only then, would you get, so you see your 1% interest all at once. And that's the key thing. With discrete change, it doesn't happen continuously over this whole time period. It just happens after whatever that interval is. Like if it was months, then every month. So that would mean for May and June, the same thing would happen. You'd still have 1010, right, in your account. But then in July, that's when you see the other increase. So that's what discrete change is. And if you think about it for population, that doesn't make sense to have discrete change because not all babies are suddenly born in December or something like this, or like on December 31st, I suppose, technically. But things like discrete change when we're talking about money, that does happen, okay? So that's the key difference there. And it leads us to these two different equations being useful in their own right. This tends to be for more discrete, but this in particular you need to remember as being for continuous change, and R is the rate, R is greater than 0 is an increase, and R is less than 0 is a decrease. Okay? Those are the key takeaways.